Now, if you have understood the lecture so far, you have all of the tools that you need in order to design a single stub matching network. We're going to do a series example here. The thing that we need to do now is put these various pieces together to design a single stub matching network. So let's assume that we have a load that is R plus JX. It's not matched to the characteristic impedance Z naught, but we want it to be. So we want our ultimate input impedance to equal Z naught so that the reflection coefficient will be equal to 0. If we normalize that, that's going to be 1 plus J0. And if we normalize this, it's going to be R plus JX. Well, in order for this to be matched, we know that our real part has to be matched. That's the first step that's the step we just did a minute ago. So the first thing we need to do is match the real part. To do that, we're just going to add a length of line, which we're going to call D, that allows the real part of our new load, our transformed load, which we can call ZL prime. We can have the ZL prime, when it's normalized, be equal to 1. So that would allow the real part to be matched. But the imaginary part is still not equal to 0, so the imaginary part is not matched at that point. Well, the way we can match the imaginary part is we can remove it. So we can remove the JX term, which is now transformed. Now it's a JX prime. We can remove the JX prime term by adding a series minus JX prime element. So let's suppose that ZL prime is 1 plus JX prime. Then the next thing that we're going to add is a series stub, open-circuited or short-circuited, which has an input impedance of minus JX prime. What that means is that Zn is going to be ZL prime plus Z of the stub, and this would be Z of the stub, and that's going to be 1 plus JX prime minus JX prime, which gives us 1 plus J0, which is the input impedance that we wanted. These are the steps in order to do a series stub circuit. Now, the only thing that changes when we are doing a parallel stub circuit is that we need to handle everything in YL instead. So if we're going to be parallel, the only difference is that we convert ZL to YL, and then we do everything else the same. The only other difference I might note, just a little bit of change. Remember that when you normalize, you use Y naught instead of Z naught when you normalize and denormalize. So this will allow us to do parallel stubs and series stubs. And what are the tools that we need? We need to be able to match the real part. That's from our previous set of slides. And we need to be able to design a transmission line, that's this transmission line right here, that has a strictly imaginary part, and that we can design its length and its load, open circuit or short circuit, so that we get the desired impedance at the front, which is this ZS right here, the minus JX prime term.